Okay, so hopefully you've had a chance now to take a look at this and figure out where the boundary of the watershed is. Um, and you can see that the ridge that this watershed boundary runs along here kind of divides up. There's a little ridge that runs out like this. There's a ridge that runs over here, and the ridge runs over here like this. So um, the watershed boundary is going to follow that ridge. Oops, I didn't do that very well. It's going to follow out here and go over in like this. I'm not doing that very precisely. Uh, and it's also going to go, I don't know, maybe something around like this over here, right? So that any rain that falls on this side to the downward side, the south side of this line, is water that's going to get funneled down into these streams, and rain that falls on the north side of that line is going to flow in the opposite direction. So now where's it going to go? Well, we've also got a ridge that runs along here. You can see running through those closed contours, right? And rain that falls to the west of those points is going to go this way, meaning it'll be out of the watershed. And rain that falls just to the east of it is going to flow through there. So we can draw a line that goes somewhere through here. And then kind of connecting those points, maybe we would just run it through like that. Let's see. So what about over here? Where would rain go that falls, let's say, right here? The rain that falls right there would go downhill and would follow some path sort of like that. So that's still in the watershed. What about rain that's over, I don't know, let's do here, or I don't know, here. There it clearly is going to go this way and be out. What about here? There it might go down like this and connect up with the first one and head down. So we're going to need to have a watershed boundary that goes over here like this. And how far will that watershed boundary go before water is flowing off the land surface downstream of this symbol? Well, it looks like here it would maybe kind of go like that. So maybe we'll draw the watershed boundary something like this over here. And where will it be over on this side? This gets a little bit tricky. If rain falls here, it's going to flow down like that and go out of our watershed. If it lands here, it's going to flow into our watershed. So we're going to need to have some path that goes, I don't know, something like that. So that's pretty close. That would be the funnel, the watershed boundary for this map. So anything that lands inside the rim of that funnel is going to flow in towards the stream, and anything that lands on the outside of that funnel is going to flow away from it. And these watershed boundaries are really important, right? Because if we're talking about protecting water quality, for example, let's say that this is this area in here is an area that is protected in some way. It's a park, or it's a protected waterway. Well, then we don't want to just not put factories and any kind of farms or anything near the stream that might foul the water, but we don't want to have anything inside this watershed that might do it. So if you're going to put a confined animal feeding operation, a CAFO, somewhere on this landscape, maybe you'd want to put it over here so that any waste produced by that site isn't going to be impacting these streams. But if you put it over here, now you are. So understanding watersheds is really important for looking at water quality. It's also important for just understanding how much water you have to deal with. The rain that falls in that site is going to impact the amount of water that flows past this point, right? So if we're thinking about flooding, we want to know how much water falls in that watershed, and then, of course, the different characteristics of the watershed, which we'll talk about in a minute, that will drain the water into that stream.